take a look at complex numbers. Complex numbers are written in the form A plus B times I, where A and B are real numbers. Alright. A complex number has two parts. It has a real part, meaning a real number, and it has an imaginary part. Or an imaginary number. And this is the way that we write it. We write the real number, then either plus or minus the imaginary number. So for example, 5 minus 2i, that's a complex number. Alright. The second part here, the imaginary part, we use the variable I for imaginary. Okay? And the variable I is actually equal to the square root of -1. So you've been told over and over through different math classes that you can't take the square root of a negative number. And you cannot if you want to get a real number answer. You cannot take the square root of a negative number, not to get a real number. But if we define an imaginary number as the square root of -1, and we use the variable I, which is I to the first power, then I squared would be equal to the square root of -1 times the square root of -1, or just -1. Alright, for what we're going to do with complex numbers, all we have to remember is that I is the square root of -1, and I squared is equal to -1. That's how the imaginary unit I is defined, and I squared. Alright, so what that would allow me to do, that you may or may not have known previously how to do, is how to write an answer for something like the square root of -16. So the square root of -16 can be written as I times the square root of 16. So I can get rid of this minus under the radical if I put an I on the outside. And then the square root of 16 is 4. So that's 4i. So the imaginary number 4i is the square root of -16. Anytime we have a negative under a radical and it's a square root, you can move that negative out or drop the negative and just put an I in front of the square root. Okay? Now, complex numbers have a real part and an imaginary part. And it's always written as the real part first, and then plus, or maybe minus, the imaginary part. As far as adding and subtracting complex numbers goes, It's basically the same as adding and subtracting variables and constants, like we have done in previous sections. For example, if I have the complex number 3 plus 2i plus 4 minus 5i, you add like terms or subtract like terms depending on the signs. So that's the real part 3 and the real part 4, and this is a plus in front. So 3 plus 4 is 7. And then look at the imaginary part. A positive 2i plus a negative 5i. As far as you're concerned, for this problem, you could think about that like it was a positive 2x and a negative 5x. You do it the same way. So 2i minus 5i is a negative 3i. So just add like terms or subtract like terms. Let's look at this one. What if I had 5 minus 5i minus negative 3 minus 8i? Now, we still need to treat negatives in front of parentheses like we do with equations. So I need to distribute this negative, or say everything inside the parentheses times negative 1 before I can do any combining of like terms. So I have 5 minus 5i, and then that's going to be plus 3 and plus, because they're both negative, 8i. Alright, so now that I've distributed my negative, now I can combine like terms. So I have a positive 5 and a positive 3. That's going to give me 8. And I have a negative 5i and a positive 8i. That's going to give me plus 3i. So my complex number is 8 plus 3i. So it's just like adding and subtracting that we've done when solving linear equations. As far as adding and subtracting goes, there's nothing different. Now, if we multiply, we have to be a little careful because if we multiply, sometimes we have to say I times I. And if you say I times I, that's just like writing x times x, which is x squared. I times I is I squared. And remember, at the very beginning, I said that I was the square root of negative 1. I squared is negative 1. So when we're multiplying complex numbers, or numbers times complex numbers, or imaginary numbers times complex numbers, if we ever have an I squared, we want to go in and plug in a negative 1 for the I squared. So for example, let's say that I had 4i times 2i minus 3. Alright, it's on the outside of the parentheses, so I want to distribute. So 4i times 2i. You can think about that like what would be 4x times 2x. Alright, at first you can think about it like that. So that's 8i squared. And then 4i times a negative 3. That's going to be a negative 12 or minus 12. 4i times a negative 3 is going to be minus 12. And then what? I. Don't leave the I off. I almost did that. Alright, now that I've multiplied 4i times both terms, if you have an I squared, plug in a negative 1. So this is 8 times negative 1 minus 12i, or negative 8 minus 12i. That's my complex number. That's written in the correct form. I have my real part and then my imaginary part. Okay. Let's look at another one. What if I had 2 plus 3i times 6 minus 7i? Okay. So this is like multiplying a binomial times a binomial. The common method that's taught in school, high school usually, is you're told to FOIL when multiplying two binomials. If you know what that means, then FOIL away. What it means is, if you think about these terms here, how they're listed, this means multiply the first terms. So you're going to want to multiply 2 times 6. 2 times 6 is 12. You're going to want to multiply the outer terms. The outer terms here would be 2 times negative 7i. So that's negative 14i. For the letter I, that means multiply the inner terms. These two terms. Multiply the inner terms. A positive 3i times a positive 6. That's positive 18i. And then multiply the last terms. The last term in each set of parentheses. So that's a positive 3i times a negative 7i. Or a negative 21. And then I times I is I squared. Alright, so first, outer, inner, last. The way that I think about that and the way that I was taught, you say this first number here times everything in the other parentheses. And then you say this next number here times everything in the other parentheses. Okay, it works either way. Alright, so now what we want to do is combine any like terms that we have. And also, if we have an I squared, we want to plug in a negative 1. Alright, so this is 12, and then a minus 14i and a positive 18i, that's going to be a positive 4i. And then minus 21 times, I have an I squared there, so times negative 1. So I have 12 plus 4i. Now negative 21 times a negative 1. Negative 21 times a negative 1 is a positive 21. So I don't leave my answer like that. Now I have a positive 12 and a positive 21 that I need to put together. So that's going to be 33. So 33 plus 4i. Now I need to write my real part and then my imaginary part. So that's right. The final answer will be real part and imaginary part. Okay. Let's see if you can do this one. Negative 5 plus 2i times 4 minus 3i. So I need to FOIL this out. So say negative 5 times 4 gives me a negative 20. Negative 5 times a negative 3i is going to give me a positive 15i. Then positive 2i times a positive 4 is a positive 8i. And a positive 2i times a negative 3i is a negative 6i squared. Alright, so I'm going to put my two I terms together. That gives me plus 23i. And I'm going to plug a negative 1 in for my I squared. So that's negative 20 plus 23i plus 6. Or, now put your two real numbers together. That's negative 12. No, negative 14 plus 23i. Alright. And make sure we leave our answers separated like that. Real part, then imaginary part. So that's multiplying complex numbers. Alright. Now, dividing complex numbers. When dividing complex numbers, we have to use a method that is very similar to what we would have to do if we wanted to rationalize a fraction that had a radical in the denominator and some other term. For example, so this isn't going to be a complex number, this is going to be just a real number, but we're going to use the same method. How would you rationalize 1 over 2 plus the square root of 3? Rationalizing a term means that you're getting the radical out of the denominator. Since there's two terms down here, you can't just multiply the top and bottom by some square root. Alright? You have to multiply by something we called a conjugate. A conjugate is the same two terms except the sign between the terms is changed. You have to multiply this conjugate times the numerator and denominator. So same two terms except change the sign between the two terms. Now doing that is going to get rid of the radical in the denominator. Alright, let me show you how. So if I multiply the numerator, I just have 2 minus the square root of 3. If I multiply the denominator, I have to FOIL this out. So I get 4 minus 2 square roots of 3 plus 2 square roots of 3, and then a positive square root of 3 times a negative square root of 3, it's going to be a negative 3. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. But since there's a minus right here, that makes that a negative. Now look what happens to the middle terms here. They cancel out. That will always happen when you multiply two conjugates, or you multiply a binomial by a conjugate. The middle terms always cancel out. So it's not really that you have to fall when you multiply those two, because we know that the middle terms always cancel out. So as a shortcut, what you could do, if you're multiplying conjugates, you can just multiply the first terms and the last terms. Alright, the middle terms always cancel out. So let's see what I have. I have 2 minus the square root of 3 over 1. 2 minus the square root of 3. So this is what we would do if we were not working with complex numbers. We do the same thing with complex numbers. Alright, so for example, let's say that I wanted to have 5 minus 2i divided by 3 plus 6i. So the way that I'm going to get rid of the I in the denominator is I'm going to multiply the numerator and denominator times the conjugate of the denominator. The conjugate of the denominator is 3 minus 6i. Now that does mean that I have to multiply a lot of stuff, but at least I can use the shortcut in the denominator. Remember, the shortcut is, if you're multiplying conjugates, you can multiply just the first terms and the last terms, because the inner and outer terms are going to cancel out. Alright, so that gives me 9. 3 times 3 is 9, and then positive 6i times negative 6i. A positive times a negative, that's negative 36i squared. Alright, now I haven't done anything with the numerator yet, so let's multiply it out. We do have to FOIL that out. So 5 times 3 is 15. 5 times a negative 6i is negative 30i. Negative 2i times 3 is negative 6i. And negative 2i times negative 6i, a negative times a negative is a positive. 2 times 6 is 12. And I times I is I squared. So negative 2i times negative 6i is a positive 12i squared. Don't forget to put the squared. Alright, so anywhere that I have like terms, like right here, I'm going to combine those. Anywhere that I have an I squared, I'm going to plug in a negative 1 in parentheses. So that's 15 minus 36i plus 12 times negative 1 over 9 minus 36 times negative 1. Where you have an I squared, you plug in a negative 1 in parentheses. Alright, so let's see what this gives us. I'm going to have 15 minus 12. What's 15 minus 12? 3 minus 36i over 15, and that's going to be a negative 12. So that's 3 minus 36i over 9. Now what's this term going to be? Negative 36 times negative 1 is a positive 36. So 9 plus 36 is 45. Alright, so I've combined like terms. Now the only problem with leaving my answer like this is that it is not in the right form. I want to write the real part and then the imaginary part. So what I have to do is I have to break this thing up. I'm going to use what's called term-wise division. That's what you can do if you have a denominator and more than one term in the numerator. You say the first term over the denominator, and then depending on the sign it's plus or minus the next term over the denominator. So that's what I'm going to do. I'm going to break it into its two terms. So that's 3 over 45 minus 36i over 45. Alright, so this term minus this term. Now I need to see, do my fractions simplify? And they do. You can divide the numerator and denominator here by 3. So the numerator becomes 1. The denominator, 3, will go into 45 15 times. The denominator becomes 15. Minus 36 over 45. So you can divide both of those by 9. So it's going to be minus 4 over 5 times I. So here's my answer in correct form. Here's my complex number. 1/15 minus 4/5 I. Let me do one more for you. Say that I have 5 plus 4i over 4 minus I. Alright, so I want to multiply by the conjugate of the denominator. So I want to multiply the numerator and denominator by 4 plus I. So I need to full out the numerator. So it's going to be 20 plus 5i plus 16i plus 4i squared. First term, outer term, inner term, last term. Over, now remember when you multiply out conjugates you can take a shortcut and just multiply first term and last term. So that would be 16 minus I squared. I times I is I squared. This was positive, this was negative, this was positive. Alright. Now I want to combine like terms and plug in a -1 for any I squared. So this is 20 plus 21i plus 4 times -1 over 16 minus -1. Alright, so that's going to be 20 plus 21i minus 4 over 16 plus 1. Right? It's a -1 times a +4, so that's minus 4. This is minus -1, so that's plus 1. So I have 20. Oh wait. So now I need to combine these two real numbers, 20 and negative 4. That's 16 plus 21i over 16 plus 1 is 17. Now, I can't leave my final answer like that because I want the real part and the imaginary part. So that's 16 over 17 plus 21 over 17 times I. Or you can think about it like 21i over 17. Either way is fine. Alright, so that's dividing complex numbers. Alright, let's say that you were asked to do this. The square root of negative 12 plus the square root of let me come up with a good one. Negative 48. Alright, so I need to first write an I on the outside and get rid of the negative. Now I need to simplify the radical. So the square root of 12 can be written as the square root of 4 times the square root of 3, because 4 times 3 is 12. The reason we break it up like that is because then I can take the square root of 4. The square root of 4 is 2. So this would be 2i square roots of 3. Alright, plus 48 can be written as the square root of, or the square root of 48 can be written as the square root of 16 times the square root of 3. Because 16 times 3 is 48. So then this is plus the square root of 16 is 4, so that's 4i square root of 3. Now, when radicals are exactly the same, then you treat them like variables. Okay? So I want to either add or subtract the numbers in the front and then just write the same radical behind it. So this is going to be 2i plus 4i. That's 6i times the square root of 3. These radicals have to be the same index, meaning that for this problem they both have to be square roots, and you have to have the same number underneath. If you don't, you can't put them together. Alright. So, what if I was given this expression? Negative 2 minus the square root of negative 3 squared. Okay, so let's look what's in the parentheses to see how we can rewrite this in terms of a complex number. Well, there's nothing I can do to the negative 2. It's just negative 2. Let's look at this term right here. I have minus square root of negative 3. So I can write an I on the outside of the radical, and that gets rid of the negative underneath. Okay, so I can rewrite square root of negative 3 as I square roots of 3. Okay, so if I want to square that, that doesn't mean just square the first term and square the second term. That means that I need to say negative 2 minus I square roots of 3 times negative 2 minus I square roots of 3. Because that's a binomial. And a binomial squared is the binomial times itself. Now I need to FOIL this out. So multiply the first terms, positive 4. Multiply the outer terms, that's a negative 2 times a negative I square root of 3. Well, we can't do anything with the radical because this doesn't have a radical. So you say negative 2 times negative 1I. So that's, when you say a negative times a negative, that's a positive. 2 times I is 2I. So that's 2I square root of 3. Now multiply the inner. Negative times a negative is a positive. I times 2 is 2I. And then that had a square root of 3. And then multiply the last terms. This is the really tricky one. The last terms here. This one and this one. Negative I times negative I is positive I squared. And then square root of 3 times square root of 3 is the square root of 9, or just 3. Now these two terms here, this term and this term, they are like terms because they both have the same radical. Right here where I have an I squared, plug in a negative 1. So this is 4 plus 4I square root of 3, because they're like terms, I have to add what's in front. And then this right here is going to be 3 times negative 1. So that's negative 3. Now put your real parts together. So that's 1 plus 4I square root of 3. And that's your final answer. That's how you leave it. You've got your real part and you've got your imaginary part. The key to getting this problem right is simplifying at the very beginning, writing it in terms of a complex number, and then FOILing. Noticing or knowing that if you square a binomial or something in parentheses where I have two terms, then I have to say that binomial times itself and FOIL that out. All right, let's look at one more type of problem, and then we'll finish this section. This next type of problem, we're going to run into this whenever we solve quadratic equations. If you can think back to how you've solved quadratic equations in the past, there's a lot of different ways. The most popular way is the quadratic formula. Okay? And the quadratic formula usually will give you something, once you've applied it, will give you something kind of like this. Now, I think you do have a plus or minus in the quadratic formula, so that's about the only difference in the quadratic formula and this right here. But you're going to have to be able to simplify something like this right here whenever we apply the quadratic formula to a quadratic equation that gives us imaginary answers or complex answers. All right? So we need to be able to simplify this. So what I'm going to do first to simplify this is I'm going to rewrite this square root of negative 50. So this is negative 25 plus, so to get rid of the negative I have to write an I in front of the radical. Now let's think, how do we simplify the square root of 50? How can we break that up? So 50, the square root of 50, can be written as the square root of 25 times the square root of 2. The square root of 25 is 5. So that's why you break it up like that. So this is going to be plus 5i over, plus 5i what? Square root of 2 over 15. Alright, so the last thing that we do, if we have a complex number that's a fraction like this, is we need to break it up to its real part and its imaginary part. That's term-wise division. We're breaking a fraction down into its multiple terms. Alright, so the way you do that, say the first number in the numerator is negative 25 over 15 plus the second number in the numerator, 5i square roots of 2 over 15. And now let's see if either fraction will simplify. You can divide the numerator and denominator of the first term, the real part, by 5. That's negative 5 over 3. For the second part, you can do the same thing. You can divide 15 and 5 by 5. So that's 5 going to 5 one time, so that's going to be just I square roots of 2 over 3. And that's my final answer. Negative 5 thirds plus I square roots of 2 over 3.